Wurtz reaction. Wurtz reaction is a coupling reaction which is developed by Charles Adolph and used in organic chemistry to prepare symmetrical alkanes. Definition of Wurtz reaction. Alkyl halides RX when treated with sodium metal in the presence of dry ether gives higher alkanes. General equation of Wurtz reaction. Rx plus 2Na plus Rx in the presence of dry ether gives Rr plus 2NaX. Rr means higher alkanes. CH3Br, that is methyl bromide, reacts with sodium metal in the presence of dry ether gives ethane CH3CH3 plus 2NaBr. Similarly, when bromoethane, that is CdHOBr, reacts with sodium metal in the presence of dry ether gives N-butane. Here N-butane stands for higher alkane. So finally, Wurtz reaction is used for the preparation of higher alkanes. And Wurtz reaction is also used for the preparation of symmetrical alkanes only. Symmetrical alkanes means organic molecules containing even number of carbon atoms. And some note points regarding Wurtz reaction. First one, the solvent dry ether must free from moisture because sodium metal reacts vigorously with water if dry ether contains any moisture. If sodium metal reacts with moisture, a flame or some little explosion also takes place. So dry ether must be free from moisture. And second one, in place of sodium metal, other metals also can be used like silver, indium, zinc, iron, etc. But side products are obtained. So generally, Wurtz reaction going on only in the presence of sodium metal. And previously, we say that Wurtz reaction is a coupling reaction. Coupling reaction means joining of two chemical species in the presence of a metal. Next, another point, we used dry ether as a solvent, but tetrahydrofuran is also used in place of dry ether. But dry ether is a good non-polar and aprotic solvent. That's why that is the main reason for usage of dry ether in Wurtz reaction. Next one, cross Wurtz reaction. When a mixture of two different alkyl halides are used, a mixture of three different alkanes are obtained. This is called cross Wurtz reaction. Example, methyl iodide and ethyl iodide reacts with sodium metal in the presence of dry ether. Then three different alkanes are obtained. They are ethane, propane, butane. The separation of these three alkanes is not easy because their boiling points are also very close. Hence, this is not used for the preparation of alkanes. This means cross Wurtz reaction is not used for the preparation of Wurtz reaction. Now we discuss about Wurtz reaction mechanism. Very important. This mechanism works when the reaction will be performed in the vapor phase. The vapor phase is considered as a suitable phase for free radical formation. What is free radical means? Free radical means an unpaired electron species which is highly reactive. Three steps are involved in the mechanism of Wurtz reaction. In step 1, a transfer of one electron from sodium metal makes alkyl free radical. Sodium atomic number 11, it contains one unpaired electrons in its valence shell. Sodium loses its one unpaired electron to alkyl halide. Then alkyl can be converted into alkyl free radical in the first step. So finally, in step 1, alkyl free radical is obtained. This can be represented in equation as Rx plus sodium gives rise to R means alkyl free radical plus NaX. So in first step, one alkyl free radical is obtained. Step 2. The second sodium atom releases one more electron to the free radical and provides a carbonium ion. In first step, alkyl free radical is obtained. This alkyl free radical reacts with sodium metal, then sodium releases its one electron to alkyl free radical, then carbonium ion is obtained. Step 3. A halide ion is displaced by carbonium ion from another alkyl halide. This is SN2 reaction. SN2 means nucleophilic substitution bimolecular reaction. What happens in step 3? A halide ion. Where was halide ion? Alkyl halide. Halide ion in alkyl halide is displaced by carbonium ion. This carbonium ion is obtained in step 2. Displaced by carbonium ion from another alkyl halide. This can be represented as R minus Na plus alkyl halide Rx gives rise to RR, that is higher alkane, plus NaX. These above 3 steps can be simply represented as like this equation. In this equation also, nucleophilic carbonium ion is obtained as an intermediate product. So these are the 3 steps involved in the mechanism of Wurtz reaction. Next one, what are the limitations of Wurtz reaction? Wurtz reaction having some limitations. What are these? First one, the reaction has relatively low yield due to the formation of multiple products. Due to the formation of multiple products, our required higher alkane or symmetrical alkane is always low yield. Second one, this reaction fails when tertiary alkyl halides are used. What are meant by tertiary alkyl halides? Tertiary alkyl halide means alkyl halide containing tertiary carbon atom. Tertiary carbon means one carbon atom surrounded by 3 other carbon atoms, that is called tertiary carbon. When this tertiary carbon present in alkyl halide, that is called tertiary alkyl halide. So what is the limitation? Second limitation of Wurtz reaction. This Wurtz reaction fails when tertiary alkyl halides are used because SN2 reaction and free radical coupling not possible due to steric hindrance. Steric hindrance means lowering of chemical reactivity due to bulky groups are present. So because of steric hindrance, tertiary alkyl halides are not suitable for the execution of Wurtz reaction. And another one, methane cannot be obtained by this Wurtz reaction. Next one, only symmetrical alkanes can be synthesized by this method. Unsymmetrical alkanes cannot be synthesized by this Wurtz reaction. Next one, if 2 dissimilar alkyl halides are taken as reactants. Dissimilar means different alkyl halides. Previously, we in Wurtz reaction 2 methyl iodides or 2 ethyl iodides are taken. But if dissimilar alkyl means 1 methyl iodide and 1 ethyl iodide reacts with sodium metal, that is called dissimilar alkyl halides. So if 2 dissimilar alkyl halides are taken as reactants, then the product is a mixture of alkanes that is often difficult to separate by fractional distillation due to their almost equal boiling points. Dry ether must be anhydrous is the another limitation of Wurtz reaction. Dry ether must be anhydrous. If moisture is present, then alkyl forms ROH instead of RR with water. So dry ether must be anhydrous. This can be represented as equation Na plus H2O gives rise to NaOH plus half H2. This NaOH reacts with alkyl halide, then ROH is obtained instead of RR, that is higher alkyl. So if dry ether contains a moisture or water molecule, then ROH is obtained instead of higher alkanes. When haloarenes means aromatic compounds contains one halogen, that is called haloarenes. When haloarenes reacts with ethereal solution of an alkyl halide in the presence of sodium metal, following reaction takes place. Haloarenes reacts with ethereal solution of an alkyl halide in the presence of sodium metal, following reaction takes place. In this reaction, one haloarene reacts with sodium metal and another alkyl halide, then 3 different products are obtained. This reaction is known as a Wurtz fittig reaction. That's all.